Hi, and welcome back to my channel. This week's problem is an interesting one, I think, and I'm going to show you a neat solution to solve this problem. Now, as you can see, it's all about finding this red area here, made up by two sectors of circles inside of a square side length 4. We've got a semicircle with a diameter of 4, the width of that square, and we've got a quarter circle with a radius of 4. Can you solve this problem? Pause the video now if you want to have a go yourself. Otherwise, I'm going to show you my solution in 3, 2, 1. Okay, so the first thing that I wanted to do with this problem is to start to label it as if it is an X and Y axis. You can see there I've put an O at D. For origin, I've put X near C for X axis and the Y near A for Y axis. Now, what that's going to allow me to do is to write down some equations for the quarter circle and the semicircle, or really the full circles, but I'm only going to consider the 2 points of intersection, which would be at D and which would be at E. And obviously D we know would be 0, 0. So really we're just worried about E. Now the first equation is of the quarter circle, and that center is at A. So there's no difference in terms of the X, but there is a difference in terms of the Y. It's 4 higher. It's at 0, 4. So our center is going to impact the equation of our circle here. So we are going to have x squared plus y minus 4 all squared is equal to the radius squared, which is r. So we get 4 squared there. Now I'm going to do the same with that semicircle. It's important to note, obviously the semicircle's got a radius of 2 and the center is going to be at 2, 0. Okay, so that's going to give us an equation of x minus 2 all squared plus y squared is equal to 2 squared, the radius squared. Okay, now from there, I've got to try and work out how to solve these equations simultaneously. Okay, now the easiest thing initially is to expand those brackets and see if we can find some way through doing that to solve these simultaneous equations. So let's expand the top one. We're going to get x squared plus y squared minus 8y plus 16 equals 16. And on the bottom, x squared minus 4x plus 4 plus y squared equals 4. Now, as you can see, on both sides of the equals, on both of the equations, we've got the same constant term. So let's cancel those constant terms out. Okay, now you can see in both of these equations, we've got an x squared and a y squared. So actually, if we subtract the two equations either way around, we're going to cancel out those x squareds and y squareds. Now I'm going to take away the second equation here from the first equation. Now, because I'm subtracting, the x squared and y squared will cancel, but also if I subtract negative 4x, I'm going to get positive 4x. And so we get 4x minus 8y equals 0. Putting the 8y on the other side will make it positive. So I get 4x equals 8y, divide by 4, and I get x is equal to 2y, which is actually going to be very useful in terms of removing one of the variables from my initial equations. So I'm going to go back to those equations here, and I'm actually only going to look at one of them. I'm going to look at the first one. So I'm going to substitute in for x 2y. I'm going to square, obviously, into 2y. That's going to give me 4y squared, which when I simplify, gives me 5y squared minus 8y equals 0. I can factorize out the y from that. So I get y brackets 5y minus 8. So either y is equal to 0 or y is equal to 8 over 5, which is 1.6. Now, earlier we had x is equal to 2y, so that will give us that x is equal to 3.2. And we're only considering here y equals to 1.6, not y equals to 0, because y equals to 0 is obviously point D, which we're not worried about. We're only looking at point E. So now we've got our coordinates, which would be 3.2 and 1.6, x first, y second. Now what I can do with that is I've put it on the diagram. I'm going to look at this chord here, D to E. Not O to E, that's just stands for the origin. So D to E. Now the length of that I can do by Pythagoras, because I've got my x, which is 3.2. So that would be the width of a triangle with this hypotenuse, and the height of the triangle will be 1.6. So square root of 3.2 squared plus 1.6 squared. That will give me the hypotenuse, which is DE. So that gives an answer of 8 root 5 over 5. So let's put that on the diagram. Now I'm going to take away the labeling for my X and Y axes there, just to make things a little bit simpler. And I'm actually going to introduce some more lines. Actually, they're the radii of the quarter circle and that semicircle. So there's the radii of the quarter circle, also a length of 4. And then this point F will be the center of my semicircle, the midpoint of the side of my square. Introduce the radius there, F to E, so that'll have a length of 2, and obviously D to F of radius would also have a length of 2. But I want to work out the angles at A and at F. When I've got those angles, I can then work out the area of the sector of each of these respective, I should say, circles, and then subtract from those the area of the triangles. And that will leave me with basically either side of the line DE, the red section either side. So let's start by working out the angles at A and F. And how am I going to do that? I'm going to use the cosine rule. And that dot, if you're not sure, that means multiplication. I wanted to put the dot in there so I don't have the C next to the C in cos, and then it all looks slightly more confusing. Now, this is for working out the side length. I don't want the side length, I want the angle. So I need to rearrange this so I've got capital A equals. Now, when you do that, you get this. So this is what I'm going to be using. Okay, so B and C, they're going to be 4. They are the two sides. And then the lowercase a is opposite my angle. So that would be 8 root 5 over 5. Let's substitute the values in, and we get this. That, when we put it in our calculator, will give us an answer of this, 53.13 ... because it goes on forever, and I don't want to truncate it. So I'm going to indicate that with the ... Let's put that on the diagram. We're going to do the same thing now with the point F, the angle F, or more specifically, DFE. So we get this. We just change B and C to being 2 because that's the radii now, or radius. That will give us an angle of 126.86. And again, I'm going to put that on the diagram, ... because the digits keep going up. Now, I'm going to start by labeling each red side, each red area, either side of that line. So I've got A1, which is the lower side, and then A2, which is the larger upper side. So I'm going to start by working out A1. Now, A1, I'm going to work it out by doing this. So angle over 360 times pi times radius squared will give me the area of the sector. Okay, and then I'm going to take away the area of the triangle DFE by doing a half AB sine C. That will leave me with the area of the segment A1. Sorry, I said take away the area of the triangle DFE. It's not DFE, excuse me. It is this triangle ADE, because we are working out A1. So we want to do the area of the sector, take away the area of the triangle. Gives you A1. I got it the wrong way around. I'm going to do that bit in a second. So that's 1.018. A2, so that is obviously A2. We're going to work that out by doing the area of the sector DEF or DFE. And we're going to take away the area of the triangle DEF. Okay. So that's going to be the angle over 360 again, times pi times radius squared, minus a half AB, which is the radii, sine of our angle. And that will give us an area of 2.82 ... So to get the red area, we need to add A1 and A2 together. So 1.018 ... add 2.8. 828 ... That gives us an answer of 3.847 to 3 decimal places units squared. Hopefully, if you tried this problem yourself, you were able to get the same solution, or same answer, sorry. If you had a different solution, not this one, share it down in the comments below. It's always great to read your different solutions. And all that's left to say is thank you so much for watching. If you enjoyed this video, please drop a like on the video. And if you're not already, please consider subscribing to the channel. Thank you so much for watching. I'll see you next Monday, 5 PM for another problem solving video. Until then, bye-bye.